So next question, a curve has a equations here. Find the coordinates of the stationary point and determine whether it is a maximum or minimum using first derivative test. So first of all, we take out our curve here, cubic curve. And to get stationary point, we need to differentiate y with respect to x. Power move to the front, power minus 1. And then we need to let this dy dx equals to 0 to find out the critical number. So we can see our quadratic is in a multiple of 18. We can simplify it by divide by 18. Then only we can do this factorization correctly. So our x will be negative 1 and 2. So once we find our x value, which is 2 and 1, then we can continue to find our coordinate y. So substitute inside the original function here. So for x equals to 2, we substitute into our functions here. Therefore, we have 2 points to be stationary point. Then to continue this, to determine whether it is maximum or minimum, we are using first derivative test. So we no longer can use second derivative test. We have to follow the questions. So to do the first derivative test, we need the table. So first of all, we identify our interval of the x. Since we have 2 points here, so we have 4 intervals. So our x negative 1 and our x 2. So 2 points we can get it 3 intervals. Okay. Because you can see this one x less than negative 1. This one is between negative 1 until 2. So this is our stationary point 2, then x more than 2. Then we can pick a test value here to substitute into our first derivative, which is our dy dx. So our dy dx is this one, 18x squared minus 18x, then minus 36. Then you come out with the conclusion. So less than negative 1, we can pick negative 2. Between negative 1 and 2, we can pick 0. More than 2, I can pick 3. So when you substitute inside, you just want to make sure you get negative or positive. So this one is negative. This one is positive. And after 2, it will be positive. So conclusion for first derivative test means the conclusion for the tangent. Positive, the tangent increasing. Negative, the tangent decreasing. So the gradient going up, the gradient going down. For positive, the gradient is going up. So you can observe here the point in the middle. The point in the middle going up, then going down. This point is maximum point. Meanwhile, for x equals to 2, it's going down and going up again. So this point can be a minimum point. So from here, we can conclude that saying negative 1, 1, 1, 1. It will be your maximum point. And then 2, 30 is the minimum point.